Here's another option that doesn't work. You could actually take a printed circuit board and basically put it there, and then that could be a heater. Of course, you'd probably actually want to put it on the bottom because heat likes to rise or whatever. There's a ton of problems with this solution though. One, it actually blocks the airflow you would have when the pack would be warm. A lot of that airflow is coming over the top here. So, you know, if you take a pack with this installed and you bring it in hot weather, well, now the fans don't actually heat it up. And even when it's cold and you're trying to blow hot air, you're basically blocking a lot of that, the channel. A lot of that air comes over the top here. So another thought would be that you could actually put this inside of here. There's actually a 130 thou gap there, and so you could put the PCB inside. That ends up having a lot of high voltage safety problems. This pack is electrically isolated from the metal here, and when you stick a PCB in there that has high voltage on it, you're asking for problems. So one thing you could do, just hypothetically, each one of these cells, you know, so let's just say 4 volts, so 4, 8, 12, or whatever, if you were to match the resistors here to where like all of the resistors right here were basically this voltage, and then all the ones there were that voltage, and the way you would do it is of course you'd have in this 48S configuration, you just have 48 resistors in series, and you'd make sure that, you know, the negative of this one was whatever, or sorry, the positive of this one was basically there. You wouldn't actually be connecting each resistor to a cell. You would just be running it, you know, in parallel or whatever. That way you don't actually have high voltage, in theory, assuming the cells are the same and you don't disconnect a connector. There's a ton of safety. All I'm getting at here is there's a ton of safety issues here. And then again, too, anything you put in here is going to prevent airflow when you're not trying to heat the pack, when you're trying to cool it. It's going to prevent that air from actually hitting these cells. So for many reasons, it just doesn't work very well. Another issue is, how do you get the wire out of here safely? You know, all of these corners here are sharp. You'd have to route this battery from module, or from module to module to module. You could even put them on top and bottom. You'd have 6 separate PCBs. You have to make 6 of these connections. It's, I mean, it'd be neat if it worked, because then you wouldn't have to have the fans running. But the fact that this counteracts the ability to cool the pack is kind of a non-starter to begin with there. Anyway, I wanted to document it just because we are in the prototyping phase, or not even, sorry, we're in the brainstorming phase here. And so here's another idea that just doesn't work. I really do. I like this option. It's not efficient because, again, we have to run the fans, and someone mentioned the half a cup of gasoline or whatever. Yeah, so the NHTSA, the NHTSA, the National Highway Traffic Safety Administration, has basically an MPGe equivalent where they say 33.1 kilowatt hours is a gallon of gas. Of course, this is an 888 watt hour, so 0.888 kilowatt hours, and so that would already be, let's get the calculator out here. If we were using 100% of the pack, it'd be 0.888 divided by 33.1, and that would be, it would be 2.68% of a gallon of gasoline, which would be about, what did I do wrong there? Blah, blah, blah. I need to divide by 100. Yeah, it'd be about 3.5 ounces of fuel. So closer to a cup. I believe a cup is 4 ounces. I'm not a baker. But regardless, it's very little power, and I certainly agree with that. And of course, the usable power is less, so that would get us down to the half a cup. If we multiplied this times 0.75, we'd get 2.5 ounces of fuel that's actually usable. My feet broke off the calc, whatever. Anyway, yeah, so if we are using more than, a kilowatt hour is, a 33rd of a gallon of gas or whatever, we'd probably be using overnight, a kilowatt hour every night you use this, but it would keep the pack healthier because it would be warm. Just a thought there. Certainly, if you're in a cold weather and you're having to heat this pack with the engine running, that's probably not going to be very efficient either, of course, unless you're driving, in which case this is going to work really well, even if you're not heating the cabin, because now we're preheating all the air going into the battery when we want to. One thing to point out, of course, this is switched by LiBCM. I think I've mentioned that a couple times, so we can control whether or not it's on. Pretty important, I would think. Anyway, yes, there's another idea that doesn't work. Thanks for watching.